Welcome, everyone. Thank you for coming to my presentation. Today, we'll be talking about Spring AI. It's a new project that will help you build AI applications and hopefully easily deploy them onto platforms such as Azure. So one way to motivate the conversation is, why do we think software developers can and should be developing AI applications? And it really comes down to a lot of advancements that we've had in the AI stack, right? That's been growing since the 60s. And here's an example of a data scientist. His name is Daniel Witnack. He hosts a very popular podcast called Practical AI. And he's been in this business for a while. He's a prominent speaker as well. And here are some quotes from an interview with him. He says, well, I go to a customer, they ask me to solve a problem. And the first thing I typically did was gather data and train a model. But this is changing right now with pre-trained models. I can solve a lot of these problems, and I can skip that step of me actually training a model. And as a result, what you see is he's now doing more of traditional software engineering, which are things that us as Java developers are quite accustomed to, and less around specific machine learning technologies that do take, in fact, quite a lot of expertise and time to learn. So the P in GPT is pre-trained, right? And that's a huge advancement. And the other advancement that I think OpenAI made is they made a very easy, public accessible API that you could access from any programming language. So that really was a game changer. And that is what's helping us to develop these applications as compared to specialists in the field. So AI applications are really going to become ubiquitous across the IT landscape. I've went to several customers already, and they're very eagerly adopting this technology. A bank I recently went to already has a few apps in production. It's moving very fast. And since Java is the language of the enterprise, it's natural for us to provide the software development and components necessary for creating AI applications. And that's what Spring AI hopes to solve. So we've probably heard a lot of news about AI in the press, and maybe you've dug a little bit deeper, but some, but not all, of the use cases that are sort of the low-hanging fruit are things like performing a question and answer chat session, but you're chatting essentially with your documents, using the information that's in your proprietary corporate store as compared to public information. Summarizing those documents is also a very popular use case. And one thing that I think we're forgetting but starting to see more of is that it's not just generating text. It can generate code. The models can generate code, images, video, audio. So all these media types are all becoming accessible for you to use as input or output. So the Spring AI application framework is open source, and it aligns with a lot of the Spring project design patterns. So if you're used to another Spring project, you'll see a lot of similar themes here. And at heart, what we do is provide a lot of component abstractions and then default implementations. And of course, you're free to write your own implementations should there not be one that we provide. And of course, we'd love any contribution should that be the case. And in fact, we've gotten many contributions to date for different components that we weren't addressing ourselves. So portability is a big aspect of what Spring brings to the table traditionally. Right now, in a way, you can think of the API landscape for all these AI models and vector databases a little bit like what was the case before there were JDBC standard. There are all these databases that had similar but different APIs. And that's the case now with chat completion. So we provide this portable way to talk to all the different models and all the different vector databases, and indeed have a portable query language. So you don't even need to learn the query language of these vector databases. You have a very SQL-like language that applies to all of them. Multimodality is what I was referring to earlier about different input and outputs types, different media types. I'll talk about function calling in a moment. Working with your documents means you have to do some data engineering. So we provide an ETL framework. And then these last 3 bullet points are areas we're working on now. Engines, which are basically helper classes that tie a lot of common use cases together, such as question and answer over your docs. Agents, which build upon that and apply sort of reasoning and access to tools to help solve the problem. And last but not least, evaluation, which is how do you know if your model is doing the right thing and not hallucinating. So here is the simplest application architecture, which already has a fair number of moving parts, but it's not too hard to wrap your head around them. You have the user request on the upper left hand, or API maybe, a computer is calling this. And it sends a message, basically a request, just like you type into a chat text box. That's transformed into a prompt, which is sort of the formal word for the input. And then that gets sent over to the model, and you get a completion. However, even already at this stage, many of these AI models have the ability to reason, let's call it. And they can say, oh, I need a piece of data, and I don't really have it. How can I get it? And that's where you register your application's functions with the model, and then the model calls back. So in Spring, this is very easy. You just expose a bean. That's a Java util function, register it with a prompt, and it'll be called at the appropriate time by the model. Once all that's done, you get the response back. And there are many AI models, Azure, OpenAI being one of them, Mistral is another, and we support all of them as much as we can down the line. So our abstraction for chat completion requests is a class called chat client, has a simple method called call. And here I'm showing the simple string example where it says, tell me a joke. And you get a string back, which is the generated content. There's also a streaming version. So again, this request and reply interaction with the model can be synchronous or asynchronous through the Flux abstraction. And there are more sophisticated prompt structures. We'll see a little bit of that later maybe, but right now, just trying to keep it very simple with strings. So to demonstrate this, I'm going to actually hopefully achieve quite a lot with a few little lines of code by use of another open source project we have called Spring CLI. It's a developer productivity tool. So you can create new applications, but not just empty shells, but new applications with code. And perhaps what's even more important is that you can go to your existing application, your brownfield application, let's call it, and add code to it. And it can do this in 3 ways. It can merge code from an existing external project. So your sample repos, let's call them. Code generation is typically done with templating. We support that as well. And hopefully we'll have time to show you how you can use AI itself to generate code. Another feature of Spring CLI, which we'll show in a moment, is user-defined commands. You can think of this as a client-side version of GitHub Actions. So typing the command Spring ASA deploy orchestrates deploying the application to Azure Spring Apps in much the same way you might use GitHub Actions to run command line tools. So this is what we'll show in the demo. We'll create a new app from scratch using the Spring CLI, typing Spring Boot new. We'll add to that existing app AI functionality for Azure. And then last, we'll deploy the app to Azure using the simple Spring ASA deploy command. So I'm going to pop out into working directory. There's a lot of functionality in this CLI that I'm not going to be able to show. But we'll start off, like I said. Oops. We'll do Spring Boot new because we're getting a new boot project. We'll call it My App. Give it a package name. So what this is going to do is go off to GitHub, get a sample project, refactor that project's package name to the one we want, and put it in the directory My App. So there it is. And we'll open this up in the IDE. And we'll go to greeting controller. Oops. And you see there's a simple controller, return something. So we'll run this. So the application started. And I'll curl it, and I get back my content. That's all fun, nothing crazy. But now what I'll do is I'll do Spring Boot add AI Azure. Before I do that, actually, let me do git init. And now I'll do Spring Boot add AI Azure. So it's getting that project, and now it's doing things by merging sections of the POM. So basically the repository section, the dependency management section, and Spring over code and refactoring that code to be in the right package. So now if I go over to my POM file, oops, no. Don't know why it's not loading. Not valid object. Never saw that before. I'll open it up here. So first of all, you get a README, which explains pretty much everything you need to do, a lot of setting of keys, and then we're going to run it. And I'll look at the POM in a moment. And here's the Spring Boot starter that was added. Normally nicer to see in the diff. And add the milestone repo. And here is the Hello World application. It's asking, tell me a joke. And then it's moving to the chat client, which you get through auto configuration in Spring, and just calling it and returning back information. So let's run this now. I already have my keys set up, so we don't have to waste time with that. Ooh, that is not what I wanted. Oh, I didn't make a typo. All right, starting up, and let's curl it. So it's going to tell us a joke. So here's a classic one for you. Why don't scientists trust atoms? It's because they make up everything. All right, lots of humor there. So let's go back to this. And what I'll do is I'm going to add a custom command. This is going to add the command Spring ASA deploy. So I'm just going to see there's a README now. It tells you what it does, but I'll walk through that in a moment. First, I need to set some keys here. Okay. So I will now type that command, Spring. Let me just do this. Maven clean package. Let's do Maven clean. All right, so Spring ASA deploy. This is going to take a little while. It might have to skip over it, but essentially there are a bunch of commands in here. Think of this as GitHub Actions. So there's ASA, right? Azure Spring Apps, deploy, and in here are things that look like GitHub Actions. You're going to see it asks a question: which resource group would you like? We're going to pick this one because it's asking for all the resource groups and then setting a variable. Then it's calling AZ Spring Create, AZ Spring App Create, and finally it's calling deploy. And you see it knows information about the project, so it can substitute the appropriate Java version number in the -- runtime version option. So that's deploying. It's going to take a while, and I can already see I'm short on time. So I think I'll go back to the slides, and then we'll just curl this endpoint in a moment later. So you can see very quickly we're able to go through all that, although wish it was even quicker. So very common request is, how do you use your data in an application? So AI models, have limitations. One of them is they're trained with information only up to a certain date. Training these models is very expensive, costs millions of dollars and huge amounts of compute resources. So you can't run a nightly job to update the model. So if you want to ask it things that it doesn't know about, what do, right? Also, it certainly doesn't know about data it's never been trained on, right? Your data, that is your proprietary information. One thing you can do, which is sort of the machine learning angle, is to what they call fine-tune the model. This means you take the weights of this entire model, and these models have billions of parameters for weights, and you start tweaking them. This is a very specialized task, usually not in the realm of software development, though it's getting easier. However, there's a cool trick which is amenable to software developers, which would be colloquially known as stuffing the prompt. Think of it as SQL injection, but for good. And so you add your data into the prompt, and now it can reason on that data as well. And this has given birth to a pattern called Retrieval Augmented Generation. RAG is the acronym, three-letter acronym that is known by. So, how do you retrieve the relevant data and add it to your prompt? There's a lot of strategies here. You start Googling for this, you can go down a big rabbit hole. So we try to make it easy and implement common strategies, and I'll demonstrate one of them now. So here's how that works, for following a diagram similar to before. You have your user request, that comes in. You get your prompt, and now you have to retrieve information that is related to that prompt. This could be your proprietary information, your proprietary documents. You get that information back from some external repository. This is typically a vector database or a knowledge graph or other documents that summarize, for example, that information, and add it to the prompt. So you get an augmented prompt. I guess that's where the word augmented comes from in the A in RAG, Retrieval Augmented Generation. You pass it over to the model, it will complete it. There's still reasoning going on there, but here I chose to highlight another capability of the AI or feature of the AI model called the context window. It's basically the amount of space you have to give it custom information. And we'll see that this is an important engineering concern because that context window is usually very limited. So then the answer comes back, and hopefully it has the information in it related to your data. Again, this context retrieval is typically done with vector databases. There's a long list of them. Most likely you have one of these maybe in your existing infrastructure. And if you don't, you need to pair up with maybe a purpose-built one. And there's a lot of selection process, and they all have great positives and negatives. So it's a little search there. So just a brief expansion on this idea of why are we going through all this extra effort? Context window, which is the amount of space you have to give it custom information, is very small, like 16K. So think back to 8-bit computers when they first came out. 8K, 16K, 32K, and it's getting larger and larger all the time, but still something you have to worry about. And this 16K refers to tokens. It's again another detail of the space, but it doesn't deal with words as you would imagine. It deals with numbers, and a token translates number to about 3/4 of a word. So do the math for the size of your document, and that's how much it will fit into. So really what you do is you have a lot more than 16K tokens of size. You have to chop up your data into smaller chunks and present these smaller chunks to the model. And this is typically what a vector database is used for. It has a process called embedding. So it converts words to vectors, and then you search. And it sounds complicated, but if you think of it in just 2 dimensions, if you have 2 vectors in X and Y coordinates and they're pointing close to each other, they're similar, right? It means those your query and that document are similar. If they're pointing away, they're not similar. So you score it, and the way you can think of it is, the first page of Google results from a query. So if we had all the articles for Wikipedia for the 2022 Winter Olympics, we would chop them up into small little pieces. A lot of heuristics here, a lot of knobs to turn. That's kind of the challenge. You create these embeddings and you store it in the vector database. We have an ETL pipeline that is specifically built for this purpose based off Java functions. Lots of implementations of the reader, transformer, and writer. Won't go into those details, but the support is there for you to do that. And what I'll do is I'll demonstrate this with an example we have out of the box for a nonprofit company that we dealt with. So it was a home care service that provides the ability to have families find someone who can help with childcare or elder care, and basically think of it as a matchmaking service. And there's definitely some involvement of the government, and this is controlled with Medicaid. And more importantly, the models have never been trained on this before. And so that's the PDF document you have here. And it's in this example app under data. Oops, I don't want to open it up, but that's the one we were just looking at. And if you ask the model without putting information in the prompt, what's the purpose of Carina, it thinks it's a constellation in the southern sky. It is clearly not a business, right? So what we can do is create this application. Where is it? Yeah, Q&A. Call it engine controller. And all the magic is sitting in this engine, right? The default question is, what is the purpose of Carina? And we go to this query engine. If we open this up, what we do is, I've already loaded it, so we don't have to spend time with that. We retrieve documents that are similar to this question. We create a context, and we create a prompt, and then we call it with the prompt. And here's where the prompt simply is. It's this text, and you see it has placeholders. So prompts typically have placeholders. This is the data that it's similar, right? The context for reasoning. And this is the question we're asking over that context. So if I just run this, let me make sure nothing else is running. Start that up. So it completed. And now I will find the little thing here. So I'm saying, what is the purpose of Carina? So instead of getting it's a constellation in the southern sky, easy to save, safe use, online care matching service. Okay, very nice. So now it knows about your document. So heading back to here. So the last little bit I'd like to show, I think I can sneak it in a few minutes, is code generation. So the models understand code really well. I mean, not many people push it to its boundaries, and I don't even think I push it to its limits either. But it knows, and Spring CLI builds upon that by writing some custom prompts and some post-processing. So you can go and say, yeah, Spring AI add, and now you say what you want pretty much, right? You type in what you'd like. What this does is it creates a README file, and you can iterate until you see this README file has what you'd like. And you can think of it in a way as a guide. You're generating a guide. And then you say Spring Guide apply. And just like the Spring Boot add command, it now adds this code into your app. So if we go here, so this is hopefully deployed now. I'll just try to do that thing. Let's see, simple. So that's calling, I guess it didn't work. Oh, well, let's go to the other stuff. Okay, so what I do is I have one of these READMEs that was generated before, because we don't have time to wait for it. And here's what it generated. So this is from a while ago, June 6th. And I just said, give me JPA functionality with an integration test. Include Java packages in the same Java code in the same packages. So like a typical README, you have to add dependencies. Now you see it creates a person object, creates a person repository, a service, a controller, and a small integration test. And it gives you a bunch of config and some links for more information. So if I, it's already done. All right. So now I do Spring Guide, apply README AI JPA. This will now make changes to the code base in a minute. So you can see it's added. I don't know why this thing is all messed up. But here's what it's added, right? In the right packages, has the test. And now if I do Spring Boot, Spring package, it's going to run that code, compile it, and you'll see some JPA stuff, flying by because we added JPA to it. So there's some loading of that, and it's going to succeed hopefully.
Well, Mark, I think you're making it too easy for Java developers to build Spring applications.
It can never be too easy, can it? But thank you for the comment. That's the goal, right? So I'm a little over time, I realize. So a lot of topics not covered. Of course, it's a huge space. It's evolving so fast. I can't imagine where this will be in a few years. So here are some links. And I really have to say thank you to the many open source contributors. It's, even though I work at Spring, it's been a long time since I've had such great interaction with so many people in the community. Yeah, feel free to check out our issues, or if there's something there that's not missing, or a lot of people do a lot of work on the documentation. Let me tell you, that's super, super appreciated. Even though I put it through Grammarly and ask ChatGPT to copy edit, things often aren't so clear, and a lot of people help with that. So I know it's a bit rushed, but thank you for attending the talk, and yeah, look forward.
Well, thank you.